welcome back to the lesson. This is Mr. Wong speaking. Today we're going to be looking at word equations and how to describe chemical reactions. So our intention is to write word equations for various types of chemical reactions. So you need to learn how to do that. The success criteria for this lesson is just being able to construct word equations for the observed chemical reactions. So what is a chemical reaction? If you actually have a look at this diagram here, a chemical reaction is the production of a new substance. Say if I have these two atoms here, or these two molecules here, I have a hydrogen molecule, and then I also have an oxygen molecule. When these combine together, you'll see that the hydrogens have broken apart from each other, the oxygen has broken apart from each other, and they've bonded with the hydrogens bonding with the water or oxygen molecules. So that's what we mean by a chemical reaction. When we produce a new molecule, or when the molecule has rearranged itself to form something else, like so. Another thing you might actually see is the number of molecules, so the number of atoms on this side is equal to the number of atoms on this side. So on my right hand side, I have 2 oxygens and 4 hydrogens. On the left hand side, I also have 4 hydrogens and 2 oxygens. Now this is something we'll talk about later on, which is called the law of conservation of mass. So the idea, conservation of mass, conservation of particles. The idea is whatever we start off with in our chemical reaction, we should get the exact same thing at the end of our chemical reaction. So the mass used is the same as the mass produced, and the number of particles we use would equal the same amount, or the number of atoms we used. Now, let's just quickly look at boiling water, okay? So boiling water is what we call a physical change, which means it's not a chemical reaction. The reason why it's not a chemical reaction, if you actually have a look here, let's say if we have cold water here and we have hot water here, the water molecules that we see here to the ones we see when it's a bit warmer, they haven't changed, right? So the hydrogen and oxygen haven't rearranged themselves. They've just gone from perhaps in cold water where they're really closely placed next to each other to when it's really hot, they're just further separated from each other like so. So they're wider away. So that's what we mean by a physical change, when you are increasing or decreasing the distance between the molecules without generating a new chemical itself. Okay, so just something you might want to write down, maybe copy it down as part of your notes. When we refer to chemical reactions, it's the production of a new substance from existing substances. Now, all chemicals start with one or more reactants. So what we're talking about is the ingredients, and it will result usually in one or more new products, which is what we're trying to produce. So if you think of like if you're cooking, if you're trying to bake a cake, you need eggs, you need flour, sugar. Those would be your reactants, and the end product, what you get, is the cake. Alright, so the next bit is obviously to try and describe a chemical reaction. Okay, So there are different ways scientists use to describe chemical reactions. Let's say, for example, the reaction of sodium metal with water. Okay, so if we look at this reaction, we can see a couple of things. One, the sodium metal has dissolved into the water, so we can see that there is a change occurring. Now, just because something dissolves doesn't necessarily mean it's a chemical reaction. You need to look for other signs as well. We can see fizzing. So if you actually look at the very bottom part here, so if you look at the bottom part of this beaker here, a little bit of fizzing of gas, you can even see the gas produced. Now, if there's fizzing, that would suggest the production of gas, in this case hydrogen. So if you see production of gas, that is an indicator of a chemical reaction. We can see that there is a flame that's also being produced. So if we see the formation of light, formation of heat, that's also another indicator that we've seen a chemical reaction. So the next bit is to obviously look at how can we describe this reaction. Okay, these are wonderful observations, don't get me wrong, and tells us that a chemical reaction has occurred, but it's not the way we express a reaction between sodium and water. What we need to do is use something called word equations. Okay, so when a chemical reaction has occurred, there's a really simple format that we use to describe the reaction. We always write the reactants on the left-hand side, and then we write the products on the right-hand side there. So remember, reactants is what materials, or in this case, chemicals, were used at the start. The products is the chemicals that form due to the reaction or after the reaction. What you might see here is a little arrow. Now this arrow is showing the progression, so it shows the progression of the reaction. So what's it showing us? It's showing us it's going from here to here. If I wrote it the other way around, so let's say in this case A to B, it means that the reaction has gone in this reaction has gone in this direction. If I wrote A and then the arrow goes in this direction, then that means the reaction has gone in the opposite direction. In this case, B would be the reactant and A would be the product. In this one up here, this scenario 1, A is our reactant, B is our product. So it all depends on where the arrow is going. Okay, the reactant is always on the tail of the arrow. The product is always next to the arrow head. If we have a look at this example here, so at the bottom here, we have sodium plus water equals to sodium hydroxide plus hydrogen. Okay, so what you can see here is on this side, that's our reactants. On this side, that is our products. So this is what we started with, and this is what we end with. Okay, and so that basically describes to us this particular reaction that we see here between sodium and water. If we have a look, word equations can be used in many different forms. So again, if we actually have a look, ideally you want it to write it all in the same line. So you can see here, this is not ideal because the word equation needs to be on the same line or on the same sentence line. So word equation needs to be on same line. So if I was to rewrite this, I would write acetic acid plus sodium carbonate or bicarbonate. In this case, those two are the reactants because they're on the tail end of the arrow. And then we have sodium acetate plus water plus carbon dioxide. And what you'll find is those are your products. That's what you get at the end of the reaction. There is a separate type of way we can express this reaction. If you actually have a look from the word equation, it does, whilst it tells me what reaction or what chemicals to use. So let's look at the benefits of using a word equation. So it tells us the chemicals used, and it also tells us the chemicals formed. And I'll do the next point in a separate color just to highlight where it's not as useful. So, but one of the issues with word equations is it doesn't say at what quantity do we produce these chemicals. So what ratio do these chemicals come in? And the reason why I'm saying this is an issue is similar to how when you're cooking, when you're making cake or something, in the instructions it will tell you the amount of eggs you need to use or the amount of flour you need to use per, the amount of sugar that is used in the cake. The word equation will tell you what chemicals you need, but it won't tell you to what quantity is required. And that's an issue with that specific example. So we actually use a thing called chemical equations. Now we're not going to talk about it today, that's for next lesson. And what you can see is in the chemical equation, it actually tells you the quantity that's given by the number in front. In this case, they're all ones. It also tells you the chemical formula. So what's the formula that makes up this chemical? So that's what we talk about when it comes to chemical equations. Alright, so that just about ends what we need to do today. Anyhow, thank you for joining in and watching through this video. Hopefully you found it helpful. If you're still quite a little bit confused in terms of where the arrow goes or what is a reactant, what is a product, or just writing a word equation in general, please feel free to rewatch the video. And until next time, stay safe and let's see the next lesson where we talk about chemical equations.